Good morning everyone. Welcome to the Foundations of Engineering 1 class. Today we have an announcement, midterm exam. Okay. Next Wednesday, March 1st, during the lab session, we're gonna have a lab midterm exam number 1. We will cover chapter 1 through chapter 8 except chapter 6. So we will skip the chapter 6. Please look at your quiz number 1 and 2, plus more questions will come. Okay, the total hour is 1 hour, and this is 15% of your final grade, so it's very important. Please be prepared. Before we go to chapter 7, let's revisit about the significant figures. Okay. As you can see, we have very long numbers. What is the significant figures here? What is the number of significant figures? 4, right? So 3, 0, 6, 0. So we have 4 significant figures. And how can you convert this number into scientific notation? So we have to change the number times 10 to the nth power, right? But we have to keep the significant figures. So for example, we have 4 significant figures here. We have to keep the 4 significant figures. So 3.060 times 10 to the negative 7th power. Alright? So here you can see we have 3.060. This is important. We have to keep the number of significant figures. Alright, let's go to the chapter 7, fundamental dimensions and base units. In this class, we are going to learn 3 things. So first, know the official SI rules. And second one is you may need to know how to express numbers using Si prefix. And third one is know how to convert a unit to different units. Okay, those are 3 learning goals. When I was in University of Michigan, my supervisor, Dr. Matt Reed, wants me to develop some computer program. That program can extract the seat dimensions. Okay. As you can see, we have a very nice 3D scan data. This is driver seat, and these are the SAE standards. We call it SAE J2732. This document provides many definitions of seat dimensions, such as W1040X, so which means W stands for width, right? So width between the insert, okay, and this is the top view of seat back, and this is front view of cushion. This is a side view of seat back. So there are many definitions of seat dimensions. So what I wanted to say here, there are many dimensions. Okay, so this is the system that I developed when I was in Michigan. This one was published in SAE technical paper. As you can see, the red points indicates landmarks to measure the width, length, height, or even radius. This process is done automatically, so we can reduce the extraction time very enormously. Alright, that was the research, but I want to say dimensions. Okay, we have 7 fundamental dimensions. What does the meaning of the fundamental dimensions? That means these 7 dimensions, it's a very basic and very unique, and these are fundamentals. So we can make any kind of dimensions using these 7 dimensions. Okay, so for example, length, mass, time, temperature, amount of substance, Probably you are familiar with this concept if you learned chemistry and the light intensity, electric current. So these 7 symbols are represent length. L stands for length, okay. M stands for mass, and here there are many units available. For example, length. There are many units such as centimeter, millimeter, meter, inch, feet, things like that. But official unit is meter. How about mass? Mass has a gram, kilogram, pound, sometimes slug. I'm not familiar with the slug, but there is some unit. Alright? These fundamental unit, we can use this unit to derive many different kind of other types of unit. We will learn that part in this last chapter, okay? In this chapter later. So what is 0 dimension? 0 dimension is just a point, okay? 1 dimension is a length, time, mass, temperature. Just 1 dimension, okay? The second dimension, the 2 dimension, is 1 dimension times the other dimension, okay? So for example, L times L. We found area. So how can we calculate the area? Width times length, okay? Or length times width. Vice versa, either ways are fine. But be careful, the answer should be L square, because it's L times L, right? How about 3 dimension? 3 dimension, it's volume, right? Width times length times height. So there are cubed. Okay, 4 dimension. Oh, it's really harder to define the 4 dimension. But let's say we have a 3D, which means volume, and then there is some time or some other other dimensions involved. Then we call it 4 dimensions. Dimensions law. Think about, we have this rectangular square. There are A, B, C number which in different units. How to find the surface area? It's easy. Concept is 2 times AB plus AC plus BC. AB is A and B and C are all dimensions, length dimensions, right? So AB is L square, okay, length square, plus AC is also length square, BC is also L square. So the result should be L square, the area. It makes sense. How about unit law? Unit has a little bit different issue. We cannot multiply different units. Alright? So for example, if we multiply inch by centimeter, it doesn't make sense. It have to be convert inch to the centimeter. So we have to have a same unit. That's why we can multiply. So here, centimeter square is centimeter times centimeter. We have to convert inch to centimeter, feet to centimeter. Okay? We have to convert it first before we multiply 2 dimensions. Okay? So unit should be same, but dimension wise it does not necessarily be same. No matter what the unit is, dimension will be same. But in unit it's not, so you have to convert unit first before you multiply 2 units. Okay. As I mentioned, that engineer, their job is solve problems. Okay, there are always problems. Engineers, they need to solve the problems. But here is a what engineers should say like this. There is some term like it is a really long length to dollars. Instead of saying like this, engineer had to say a number like Dallas is about 411 miles away from Corpus Christi. Okay? And the other example is set the oven to a high temperature. How much high temperature? So engineer should say set the oven to 450 Fahrenheit. Okay? So here's you get another example. Gas Monkey Garage. I like these two guys. They are very good at, in both engineering and business. So probably you saw this show before. Basically what they are doing is they are buying an old car in cheap and then revamp it and sell it in a great shape. Okay? But if you listen very carefully, what they are saying is they always say a number and the units. So for example, this Ford Mustang has 280 to 375 horsepower range, and there are 17 to 22 inch diameter wheel, things like that. So in we are engineers, so when we want to sell something or make a presentation, you have to be very clear, because the client wants to know every single details about the car, right? In this case, the car. Okay, so give me the money. There is some issues. If you go to China, Chinese people, they are familiar to use kilometers. It's different from what Americans do. In the United States, we are familiar with miles, right? Not kilometers. How about the temperature? In South Korea, we used Celsius degree, not Fahrenheit. But in the US, we use the Fahrenheit, right? This is one of the good examples showing that the boundary number in boundary shows kilometer per hour. But how about inside? Inside shows mile per hours. Okay, this is to me it's a little confusing, but it's good to know to both units at the same time. Okay. Here you can see the red one indicates right-handed traffic, kilometers. Right-handed traffic, miles. This orange only this small few countries used right-hand traffic and miles, and this left-hand traffic, kilometers. Left-hand traffic, miles. Okay, so as you can see, the red has a large portion. Okay, so right-hand traffic, kilometers. Only Burma, Liberia, and the United States have officially adopted the miles. How about the temperature? In temperature-wise, it's more worse. Only a few countries like Bahamas and the United States have officially adopted Fahrenheit. All right. And there are several different unit systems. So, as you know, the SI, International Standard Unit System, AES stands for American Engineering System, USCS, United States Customary System, though there are 3 different systems. So in the length, SI system, we call it meters. AES, the length, the standard measure is foot. In the USCS, the standard measure for length is foot. Okay, there's a little different system, just for your knowledge. Okay, so let's practice here. We have a Si prefix table, and we have a standard notation number of around 43 million meter. How can you convert this number into scientific notations? 2, 3, 1, 2, 3, 1. So 7 place forward. So then we can find 4.348 times 10 to the 7 meters. Okay. How about in engineering notation? In engineering notation, we can use the superscript number should be multiple of 3. So 3, 6, 9, 12. So 43.48 times 10 to the 6 meters. How about Si prefix here? Here you can see we have a 10 to the 6th power. We call it mega, the uppercase M. So we have a meter here. In Si prefix, we can say 43.48 megameters. Okay. Here is some example you need to avoid. For example, 43 terameters. We have 43 terameters. Okay. What's the issues? The first, we cannot combine two different Si prefix to express this number. For example, 43 kilo gigameters. It doesn't make sense. Okay, we have to only use one Si prefix. Do not combine multiple Si prefix. How about 43 terameters S? You can see the S here. We don't need to put the S in the shorter sense, in the short one. Just say 43 terameters. That's it. That's fine. Another quiz is, so we have a 5 millimeter versus 5 millimeter. There is a space, there is no space. Which one is right? In technical writing, the left one is right. So that's how we designed it that way. We have to put one space between number and the unit. But how about in temperature? In temperature, we don't need to put the space between number and the degree. Okay. There are several other units. For example, have you heard about the AMU before? AMU for mass. So atomic mass unit. We are going to learn this concept later. This is some other different units. Okay, let's skip this part. Alright, now we are going to learn the conversion. So my weight, Dr. Park's weight is in pound is 161 pounds. But I want to convert this number to kilogram. Okay, how to convert this unit in pound to the kilogram? We have to know about conversion factor. So how 1 pound means to kilogram, 0.45 kilograms. So this is a ratio. So simply we just multiply 161 times this conversion factor, then we can find unit in kilogram. Okay, 73 kilogram. It's really that easy. So rounded to the two significant figure, we can find 73 kilogram. Okay, it's very simple. Let's look at another example. Mariana Trench. This is the most deepest area in the world. It's 35,000 feet. 35,000 feet. Wow, it looks like very deep. But I want to know I want to know in miles. Okay, I want to convert this unit to miles. Rounded the two significant figures. Okay. Here you can see Titanic resting in depth of Titanic is 12,000, and the height of Mountain Everest is 29,000, and this Mariana Trench is 36,000. Okay, let's see how much mile it is. So we want to know the conversion factor. What is 1 feet? Is 2 miles. 0.00189394 mile. Okay, we have a conversion factor. So what can we do? We just simply multiply 35,000 to times 0.00189, which means it's 6.7873 mile. So in mile, rounded with 2 significant figures, 6.8 miles. Okay, cool. I think many of you had a really hard time to convert cubic to inch, right? To calculate the volume of Noah's Ark in the last lab sessions. So here I would like to show you how to convert unit from cubic to meter. But in this time I would like to convert it twice. First I will convert the cubic to inch, and then I will convert it to meter. Alright, so we have the length of Noah's Ark, let's say 300 cubit. We want to change this one to inch, so 300 cubit times 18 inch per 1 cubit. It's a conversion ratio. So we delete this cubic unit, and also we want to convert it into meters. So 1 inch is 0.0254 meters. So this is conversion factor. So we can delete inch because nominator, denominator, we can erase these 2 units. So last unit is meter, right? So 137 meter rounded to 3 significant figures. Wow, this is quite long. So let's calculate the Noah's Ark volume and the human's volume. Okay, here you can see the ark has a length, width, height dimensions, and this is the unit. This is the human's dimension, length, width, height, and this is the unit, meter. So how can you calculate the volume? We can just simply multiply length times width times height, right? So here you can see 300 times 18, which means in inch, and we also multiply again 0.0254, which is converted to meter ultimately. So these are lengths, these are width, these are height. So we have 43,000 cubic meters. This is the volume of the Noah's Ark. How about the human's volume? Human's volume is 0.3 times 0.3 times 1.7 height, so 0.153 meters. So we can, how many people get fit into the Noah's Ark? It's 280,000 people. I know it's ethically wrong if we stack the people into the Noah's Ark, but in calculation wise, we want to put as many as people we can. So the maximum number is 280,000 people can fit into the Noah's Ark. Alright. And another example was fill the pond with water from kitchen faucet. The area of the pond is 10 acre. Acre is actually the unit of area, right? We can convert it to meter square, around 40,000 meter square. And the deep is 5 feet. So 5 feet pond means the feet, we can convert it to meter, right? So 5 feet is equal to 1.5 meters. The volume in the cubic meter is 61,000 cubic meters. This is the volume of pond, 10 acre pond with 5 feet deep. Now we are going to use the kitchen faucet to fill this pond. So how long it will take? So first we have to assume how much water came from the kitchen faucet per minute. So according to the conserve H2O defines that maximum gallon per minute of the kitchen faucet is 2.5 gallon per minute. So we can convert it to how much gallon per hour, and we can change this gallon to cubic meters because the gallon itself is volume, right? So 0.57 cubic meter per hour. How long it will take to fill this pond? Well, we can convert it, calculate it, days, hours, days, and it takes around 12 years. Alright, it's interesting part. And the other thing is I'd like to show you some mobile app. Everybody has a mobile phone, and this is a free app. Basically, this app can convert any length or weight unit from other side. Okay, where still I'm not familiar with the height. My height to the feet. Okay. So when I always change my driver license, they ask me to write my height in feet, right? I know my height in centimeter, but I'm not familiar with to convert this centimeter to feet. I always use this mobile app. It's very simple and easy. The last thing you need to know is the derived dimension and the unit. So we learned 7 fundamental dimensions: length, mass, temperature, time, right? So we have these 7 fundamental unit. We can derive other types of unit using these 7 fundamental dimensions. So for example, everybody knows about what is a force is. A force is mass times accelerations. Here you can see. Energy, what is energy? Energy is force times distance. Power is energy times energy divided by times. Pressure is force divided by area. Voltage is power divided by the current. So this is a basic concept in basic physics. So let's look at the force first. Oh, by the way, we can describe this force. A force is mass times acceleration. Mass we can express this mass is uppercase M. What is L divided by T square? L stands for length, and the T stands for time. Okay, time square. So it's very familiar to look at this equation, length divided by time square. That is acceleration actually. So mass times accelerations. Let's look at how we come up with those dimensions. Okay. As I mentioned before, acceleration is, for example, meter divided by second square. So think about gravity. Gravity is, everybody knows gravity is 9.8 meter divided by second square, right? So in this case, meter is length, right? Meter, the unit meter is one of the unit of length, right? The second is also one of the unit of time, right? So L divided by T squared. How about the force? Force is mass times accelerations. Here we have acceleration. Kilogram is a mass, right? Kilogram is one unit of mass. So we can say force is m times L divided by T square. So this is dimension of force. As I mentioned before, dimensions should be same. Even though we have a different unit for acceleration, for example, it can be a meter, it can be an inch, or it can be a miles. Also, you can see the times. It can be a second, it can be a hour, it can be a minute. It's very different. It can be varied, but dimension-wise, it should be same format. Okay, L divided by T square. How about the force? Yeah, unit-wise, it can be varied. Sometimes we can say for Newton or pound force, but dimension-wise, it should be same. M times L divided by T square. What is the acceleration force? The acceleration, we have 1L and then negative 2. Negative 2 means because it's in the denominators, so that's why I said negative 2. Here, force, we have 1 m, which is mass, we have 1 length, and then negative 2 time. Okay. How about the pressure? Pressure is force divided by area. Okay, so this is force, what we just looking at. Force meter times L length divided by T square divided by area is length square. So let's use kilogram, meter, second here. So we can calculate the denominator, numerator, and we can convert, we can delete m. Here we have 1 kilogram, 1 meter, and 2 times. Okay, so m divided by L times T square. Here we have 1m and the negative 1L and the negative 2T. How about the energy? Energy, as I mentioned before, energy is force times distance. This is the force. We just choose the one of the unit for mass, length, and the time, right? So we can calculate it. The joule is mass. We have 2 lengths dimension, and we have 2 times dimensions. So energy, we can express energy as m times L square divided by T square. These are the same. No matter what the unit of energy is, these dimensions are the same. Okay. Homework, there are homework number 3. What if we have these 4 different units and multiply it? Then what is the final dimensions? Here you can see we have length divided by T square times square. Okay, m divided by second square is length divided by times square. Feet is length, and the gallon is volume, right? Volume. So it's L cubed divided by time. And here we have a kilogram. Kilogram is mass, right? And L is length. So mass divided by L cubed. If we multiply these 4 different units and different dimensions, what dimension for in this area? We have 5 different dimensions. It should be one of them. The answer should be one of them. Okay. So due date is this Wednesday before the lab class. Please submit your work on Blackboard. Today we learned 3 things. First, we know the official SI rules. And second, we know how to express numbers using Si prefix. And the third one is we know how to convert the unit to other different units. Thanks for watching this short video. See you next time.